In this video, I'm going to construct a simple trading system. I'll basically be following Rob's introduction from his PySystemTrade GitHub. There's the link to that page. A comprehensive trading system is composed of multiple trading rules deployed across multiple instruments and is underpinned by several stages. Firstly, pre-processing some raw data. Secondly, running some trading rules to generate forecasts. Thirdly, scaling and capping those forecasts, and so on. We will explore stage 1, pre-processing some raw data, some other time. For now, we will just rely on this ready-made futures price data. From sysdata, import CSV futures sim data. Data equals CSV futures sim data. So this data object will serve the role of data. Let's kick off for real with stage 2, running some trading rules to generate forecasts. In my third video in this series, I discussed the moving average crossover trading rule, EWMAC. I explored line by line a function within PySystemTrade called calc EWMAC forecast. In brief, this function ingests a price series, works out the difference between a fast and a slow, exponentially weighted moving average, and then spits out a forecast. However, with PySystemTrade, you can import a very similar ready-made EWMAC trading rule in which the default look-back windows are 32 days for the fast moving average and 128 days for the slower moving average. And that is imported with the following line of code: from systems.import EWMAC forecast with defaults as EWMAC. So rather than faffing around with the calc EWMAC forecast function, we'll just rely on this imported EWMAC rule. By the way, I like to run help on objects that I'm unfamiliar with, which I have done frequently in this video. It's just worth noting that when I run it on EWMAC, indeed, it's true, the default settings for the fast moving average equals 32 days and for the slow equals 128 days. A trading system implies we have more than one trading rule. So we need to import trading rule so that we can easily define individual trading rules. From systems.tradingrules, import trading rule. I run help on that, and I have skimmed this text. But briefly, the trading rule object, actually a class, contains 3 elements. Function, meaning the trading rule we'd like to use. Data, meaning the price data. And other args, an optional dictionary of arguments that allows us to tailor the trading rule. So let's go ahead and define 2 trading rules. EWMAC 8 is equal to trading rule, and then we pass a dictionary in which we specify the 3 elements I just mentioned. Function, EWMAC in our case. Data, which is an empty list in this case, and other args. And for the first trading rule, the fast moving average has a look back window of 8 days and a slow window of 32 days, and the other trading rule has the 32 days and 128 days. Notice it's not a problem at this stage that we've left data empty. Notice also that for completeness I did specify the fast and the slow moving average look back windows for both trading rules, but if I hadn't bothered, then they would have defaulted to 32 days and 128 days, because as we saw, this function has that as the default setting. Next, we want to combine these 2 trading rules into a single set of trading rules. To do this, we need to import rules. From systems.forecasting, import rules. Rules is a class. The way I think about rules is, whereas we started by importing trading rule, which has singular connotations, as in we define individual trading rules, with the rules class, it has connotations of a plurality of trading rules, and hence allows you to define a set of rules. So At this point, we have imported the tools we need to define a set of trading rules, and we do so in this line here. My rules is equal to rules, and then we pass this dictionary in which we reference the two trading rules that we individually defined using TradingRule. Let's take a quick look at some of the methods available for this object, my rules. Directory my rules, see a long list here. I notice get raw forecast is familiar. And how about trading rules? Well, experimentally, let's try this one. My rules dot trading rules, and it spits out this, just regurgitating the two trading rules that we have added to this set of rules, EWMAC 8 and EWMAC 32. And it just tells you a bit about the provenance of each of those trading rules, that they are derived from the function EWMAC forecast with defaults. They rely on daily price data to function, and the key other arguments for both of these rules is the look back windows for the fast and the slow moving averages. Now we have a set of rules, but a trading system also needs data, so we import system, which will enable us to tie together the rules and the data from systems.baseSystem import system. My system equals system, and then pass the rules and the data. To define my system, I feed the trading rules and the futures data objects that we assigned at the very beginning. We simply called it data. Let's take briefly stock of everything we've done up to this point, because it's quite a bit. Firstly, we used TradingRule to individually define two trading rules, which we called EWMAC 8 and EWMAC 32. Secondly, we used rules to combine these two trading rules into a set of trading rules, which we called my rules. Thirdly, we used system to tie together our set of trading rules, my rules, with some price data, which we called data. And we called the resulting object my system. With this my system object, we can reference specific stages of the system, for example, the rules stage, and also specific methods available to that stage, such as get raw forecast. Case in point, my system.rules.get raw forecast for the instrument euro-dollar for the trading rule EWMAC 8, and just show the last 10 values, which it does. Then negative values. It seems that this rule wants us to be short euro-dollar at the moment. Notice that we can refer to specific instruments and trading rules so long as they exist within our system. By that I mean I could and will change this to gold, and I'll change this to EWMAC 32, and sure enough it works just fine. I'd like to plot a few curves showing the raw forecasts because I want to see what they actually look like. So I do, first of all, for euro-dollar, EWMAC 8, and it fluctuates over the last few decades between -6 and +6. For euro-dollar EWMAC 32, it fluctuates between -5 and +15. It's less erratic, which I would expect because this is a slower trading rule. Not quite as sensitive as EWMAC 8. I've done the same for gold, just for completeness really, and I have done another plot here for the instrument mummy EWMAC 8. This one we didn't have quite as much historical data to plot, only as far back as 2018. I suppose my point is the y-axis is a little different in each case, isn't it? Sometimes the forecasts, the raw forecasts, vary between -5 and +15. Sometimes for some instruments and some trading rules, the values are a little bit different, -10, -4. Okay, let's move on now to the idea of config objects. To quote Rob's GitHub page, a config object allows us to control the behavior of the various stages in the system, meaning the 7 stages that I defined at the start of this video. And by the way, if I run help system, it does say here systems are made up of stages. They take data and optionally a config object. So at Rob's GitHub page, when it talks about config object, this is exactly what it's talking about here. So to make a configuration object, we have to import config from sysdata, and then we assign config to an object we call myconfig, and it can be used to define trading rules, as we're about to see. myconfig.tradingrules is equal to a dictionary containing the two trading rules we created. My understanding is that this line right here is basically similar to the line that we ran earlier. My rules equals rules, dictionary, rule 1, rule 2. Both lines define a set of trading rules, except in this line, those rules are being embedded within the myconfig object. myconfig.tradingrules, it regurgitates the two trading rules, and this is exactly the same as what we got when we ran myrules.tradingrules. Oh. So if we wanted to define a trading system using the config approach, this is how we would do it. We define an empty set of rules. Yes, this is weird, I know, but bear with me. Empty rules equals rules, nothing. Next, we define the mySystem object. MySystem equals system, empty rules, data, myconfig. Notice we feed a set of rules just like we did before, but this time the set of rules we are feeding in is empty rules. The other difference is we are feeding in this third element, myconfig. myconfig.tradingrules, this here, is what is telling system what our set of trading rules is, because it's not getting it from this because this is empty. Why did we bother at all specifying empty rules? Why not just stick with the way we were doing it before, which was this way? MySystem equals system, my rules, data. I don't know. If I had to guess, I would hazard two answers. Answer 1, the system object simply has to be fed a set of rules object, even if it's an empty set. And my second answer would be the config approach is a more powerful way of doing things, of defining a system, and will pay dividends as we get better at PySystemTrade. That's my guess, but let's get on with it without questioning this anymore for now. Just to prove that my system object works as normal, despite the strange way that we configured it using myconfig, I'm going to run mysystem.rules.getRawForecast. And the values are the same. That it's still telling us exactly what it told us before, be a little bit short $. At this point, I'd like to do a stock take and make sure some references and make some references to Rob's book, Systematic Trading. Here's a screenshot from his book. This is a bird's eye view of a typical trading system framework. There's lots of parts to it. But the point I want to emphasize is that in the code we've looked at so far, we've pretty much done two important bits of this framework. We have defined a couple of trading rules, and we have therefore been able to generate raw forecasts for instrument X, $, in this case. To be more technically correct, I would say that we have actually defined two variations of the same trading rule, whereby EWMAC is the trading rule and the 8-day, 32-day combination and 32-day, 128-day combination are the two variations. So it's in complete agreement with this highlighted box here. We have one trading rule, EWMAC, but two variations. And we have so far been able to generate the raw forecasts for each of these trading rule variations. So far in the video, we've generated raw forecasts for two trading rule variations. The raw forecasts are volatility adjusted. That's something I explored in detail in video 3. But just as a recap, one way I like to think about volatility adjusting our forecasts runs as follows. Suppose you are using the same trading rule, EWMAC, on two different instruments. One instrument is wild, the other is flat and boring. Suppose the gap between the fast and the slow moving averages today happens to be identical in the case of each instrument. Does it make sense that the forecast is therefore identical for each instrument? I don't think it does. The forecast needs to take into account the inherent volatility of the given instrument. If it's a very volatile instrument, this particular gap between the fast and the slow moving average might not be a strong indicator of anything. If it's usually a very boring instrument, then that gap might equate to a strong buy signal. So obviously it's important to do the volatility adjustment for these raw forecasts. Although the forecasts are volatility adjusted, they need further massaging to be fit for purpose. Rob's book, Chapter 7, recommends scaling and capping the forecasts. The scaling is done in such a way that forecasts are calibrated to have an average absolute value of 10. In other words, a typical buy signal will be plus 10 and a typical sell signal will be minus 10. Furthermore, Rob imposes a cap on the forecasts so that the buy signal cannot be any stronger than plus 20 and the sell signal can't be any stronger than minus 20. Obviously, a forecast of 0 implies you don't take any position at all. Recall that capping and scaling forecasts is the third stage of the 7 stages of any trading system. And by the way, just a few more words about this. Scaling and capping forecasts is helpful for at least one reason, because then you have consistency in the forecasts that you get for your different trading rules and your different instruments, whereas in the raw forecast format, as we saw with these plots, the numbers are just quite inconsistent. -6 to +6 for euro dollar EWMAC 8, -10 to +10 for gold EWMAC 32, -4 to +6 mummy EWMAC 8. Wouldn't it be much better if all of these were running from -20 to +20 and they were distributed in such a way, these forecasts, that +10 was a typical buy signal and -10 was a typical sell signal? Anyway, going back to where we were, this system is now equipped to generate, to add this capping and scaling forecast stage to our system. We run the following code: from systems, import forecast scale cap. myconfig.instruments equals these several instruments. myconfig.useForecast scale estimates equals true. I'll speak a bit more about this later. FCS equals forecast scale cap. And this is the crucial bit. My system is equal to system. And now we're not only feeding that empty set of rules, but we're also feeding FCS, this additional stage of forecasting and of scaling and capping the forecasts. And as normal, we pass the data and the myconfig object. The system is now equipped to generate forecasts that have been scaled and capped. Let's test it. mysystem.forecastScaleCap.getCappedForecast for euro dollar EWMAC 8 shows this. For the last 10 rows, the forecast is now ranging between -20 and +20, and we can see that this is actually quite a strong to / typical sell signal for euro dollar. And let's plot these for good measure. Again, as before, but now the forecast for euro dollar EWMAC 8 is scaled between -20 and +20. In theory, some of these forecasts they wanted to go higher than plus 20, or they wanted to go lower than minus 20, but Rob does not permit that. He caps it because he doesn't want the system compelling you to take on very large positions, either long or short, because it can spell disaster. And a similar plot, but for the EWMAC32 rule, again, scaled between minus 20 and plus 20. To wrap up this video, let's spend a few minutes dwelling on these lines of code that we just ran. What were they actually talking about? These two lines are the weird ones, aren't they? Why have we specified myconfig.instruments is equal to these several instruments? And what's this bit about? Use forecast scale estimates equals true. Well, I think what these lines are talking about is what Rob calls forecast scalars. His book explains this in more detail, but in brief, as we've discussed already, your trading rules generate volatility-adjusted raw forecasts. At Rob's direction, we need to rescale those raw forecasts so that their average absolute value is around 10, and we want to impose a cap of plus or minus 20. You do this by multiplying the raw forecast by a forecast scalar. To find the appropriate forecast scalar requires that you backtest the behavior of the given trading rule to find out what its average forecast over a long period of time has been. When you are backtesting the behavior of that trading rule, it is best practice to use many instruments and take the average value from those backtests. Hence, we have specified a bunch of instruments here, and it probably would have been better if we'd specified even more instruments than this. To understand this line about use forecast scale estimates equals true, ask yourself what it means if it was set to false. If it was false, then the forecast scalars would be fixed values that Rob derived from his extensive research and which he reports in his book in this table. Forecast scalars for different EWMAC lookback pairs. And for EWMAC 832, the forecast scalar is 5.3. For EWMAC 32-128, it's 2.65. By the way, this topic of forecast scalars has been hotly debated on one of Rob Carver's blog posts. So this is a nuance of the trading system that apparently has a lot of depth to it, and you can think about it for hours and hours and hours and still be coming up with new ideas. Just the final point to make. When I run mysystem.forecastScaleCap.getForecastScalar for Eurodollar EWMAC32, the scalar value comes out at 2.99, and I'm quite happy with that because it was based on this selection of instruments, and it's similar to the fixed value for this trading rule, EWMAC32, that Rob came up with and published in his book, 2.99, not too dissimilar from 2.65. That's the end of this video.